Hello, good evening. Good evening to all of you. Last week we have done until page 60 something, and my homework was page 110 until 130. So, some of you doing this, quite okay. You do, then I mark for you already. But it is really a lot. Not I don't want to do. I cannot. If I do this, at least I need how many 2 to 3 lessons to do it. So I'm gonna skip this the one that I don't ask you to do, but I will find some objective to do first, because of I think what I think it is important I want to discuss with you one. All right, let me find the one that I want to discuss one. Okay, we do some. I pick up some lah. All right, I pick up some. Page 77. Page 77. All right. Diagram 19 shows a boy of the weight 200 Newton is going down on an inclined plane at an angle of 30 from the horizontal surface, frictional force of 20. Which of the equation it is the net force of the boy when it moves down along the inclined plane? All right. So now I label all the forces in first. All right. So this is the weight. How much is the weight? The weight is 200 Newton. All right. So I put in 200. And then what is this? This is your reaction. So this one is R. And then what is this? This is your frictional force, right? So this one, it is your frictional force. How much is the frictional force? Frictional force, it is 20. All right, we put in 20. All right, so what do they want? Which equation is correct to calculate the net force, right? What is the net force going downward? Net force going downward, F is equal to ma, is the force that going downward this way, right? So F is equal to ma. Now F is your net force, but they don't ask you the acceleration, so you don't need. So you just F is equal to ma, right? F net force is equals to the net force is equals to the force that going this way, here, right? So we know that this one is the angle, right? Wait, I haven't put in the angle yet. This is our angle here. This angle is 30. We put it in first. Right, put it in first, 30. So now F is equals to the net force is equivalent to this force. The force that going down here, bring to here. All right, 200. Touch or not touch? Not touching. Not touching, we use sine, right? 200 sine 30 minus 20. 200 sine 30 minus 20. That's all. Right? 200 sine 30 minus 30. That's all. Right? You need to know how to label all the forces in, and then you need to know how to resolute it. Okay? So I am going to skip this. I want to do one more, which is, I think it is important one. This one I don't want to do. I do some that is important. I tell you first. Of course, if you do it, then I'll mark it for you. I told you that is a lot. Wait, this question. This one is the one that I want. I want to discuss with you because of it is important. Right? Page 89. H at D9. Right, number question 21. All right, I discuss. Now, diagram shows the housewife cleaning the floor. All right, so what is a forward force? So forward force is here. Now, this one is the force that you push downward. Right, the force that the mop you are going to push downward. So this is a forward force, Fx. All right, Fx. This one is Fy. Fy, touch. Fy, touch. Touch, we use cos. Right, so I am going to do both for you. So Fy is equals to F cos theta. Right, Fy is equals to F cos theta, but they want Fx, right? So don't have. So I need to put a Fx. Fx is equals to F, I bring to here. This one, bring to here. Not touching, we use sine, right? Sine theta. But you don't have answer also. F sine theta, F sine theta, F sine theta, F sine theta. Don't have. Now, we know that this one is 90 degree. This one is 90 degree. So this is theta. Of course, this one is 90 minus theta here. This one is 90 minus theta. So if you bring this one to here, this force you bring to here, touch. Touch what? Touch 90 minus theta. Touch 90 minus theta. It is Fx is equals to F cos. Touch 90 minus theta. So 90 minus theta, cos 90 minus theta. This is the answer C. C. Okay, now not only this, I want to discuss one more thing here, which is I think it is important. Now here, that is a force that you push the mop, right? So of course you ask me, this one, teacher, this one is a mop. Can I pull it? Yeah, if you pull it, the floor will be not clean. I repeat. So if you want to mop the floor, the force that apply, it is push downward. Okay, so we try to calculate, right? We try to calculate. So the force that used to mop the floor, we name it as R. For example, this one I put it as, this force I put it as 20 Newton or whatever, right? 20 Newton. Now this one got a weight, all right? Also let's say 10 Newton, right? 10 Newton. Right, 10 Newton. So 20 Newton, the F is 20 Newton. You apply the weight, weight is 10 Newton or whatever. I just simply say this angle, I put it as 30 degree. We try to calculate. So I draw the force first. Now one is go upward, the other one is going downward. We see which one is more effective, right? And the angle here, I just put it at 30 degree. All right, this 30 degree. This one is 30 degree. This one is 30 degree. Okay. Now this one is a force. This one is a force, right? We try to calculate if you pull, how much work that you have done, right? How much force that you have done, right? Okay, now we know that that is a weight downward, right? Weight is going downward, right? As I told you, it is 20 Newton. Okay, so no more other force. So that is one more force. Now there is a friction, but I don't want to talk about the friction because of it is useless here. Right, so this one is R. So I want to calculate which one has a higher R. Okay, now the force that going up, F not touching 30, F not touching 30, F not touching 30, we use sine 30. F sine 30 plus R is equals to, why plus R? Because R going up, F going up, right? Is equals to the force that going down, 20, right? R is, this F, I told you it is 20, yeah. Okay, 20. Okay. The weight is 10, weight is 10. Sorry. I said 20. 10. Sorry, Okay. So, now, what happened is, I bring this one to here, right? 10 minus 20 sine 30. So, 10 minus 20 sine 30, it is 0. Right? Oh, I changed the number lah. I changed this one to 20 also lah. 20. I'm sorry, I changed it to 20 because of if 0, not so nice. So I put it as 20 lah. Okay. 20 minus 20 sine 30. 20 minus 20 sine 30. It is equals to 10. Alright. It is equals to 10. Okay. Now this force, which direction it is going? So this force, it is going downward, right? The force that going downward is here also, right? The total force that going downward is F, right? F, I repeat, F. Now, I bring downward here. Now, do I touch 30? So, you see, this one is, this one is 30. This one is 30. So, Z, right here, 30. Now, I bring this force downward. Do I touch 30? No, right? No, I use sine. So, F sine 30, that's going down, plus 20 also going down, is my R. So, how much is R? F, I told you it is 20. 20 sine 30. 20 sine 30 plus 20. You got 30. Okay. Excuse me. So, the question come already. Which one you pull or you push, it is more effective for you to mop the floor? Of course, it is pushing. Why? Because when you are pushing, so the force here, it is same direction downward, right? Pressing downward. If you are pulling, if your mother asks you, hey boy, help me to clean the floor, okay, mop the floor, okay, you just wet the mop and then you pull. So easy. Where got so little force, only 10 Newton only. But if you push the floor, push the mop, you are using 30 Newton. So it is more harder for you to do so. Alright, so more effective. Right? Okay. So I hope you can understand this. This one, it is contribute to, okay, this one enough already. So we try to do the one that I asked you to do. Page, my homework is page 110, right? Yeah, the one that I circled, 110. So we start from here. Okay, we start from here. Okay. Diagram 7.1a, 7.1b shows the two identical frames that are hanging on the wall using the string of the same length. T, and then T here. Alright. So the two photo frames are in equilibrium state. Each photo has the mass of 2 kg. 2 kg here, 2 kg here. Each string can withstand a maximum force 15 Newton. Alright. So now can tahan 15 only. More than 15, it cannot tahan already. Alright. So now this one is the weight. The mass is 2 kg, yeah. Photo frame, 2 kg, yeah. Right. So weight. Now what is mean by equilibrium state? Right. Equilibrium. Net force act on the system is equal to 0. Right. This is called equilibrium. Net force 0. Right. Net force 0. Next one. In the space, draw the triangle of forces. They want triangle only. Yeah? Okay. Now I draw this. T1, T1, and then W. Okay. Right. T1, W, and then T1. So this one. Okay. Now this one, the anchor put it in. Alright. So this one how many mark? How many mark? Right. 2 mark. Oh, 2 mark only lah. If more than 2 mark, alright, 1 mark each. If this one is 2 mark, your anchor must be all in. But if you don't, they don't ask you the anchor, you also put in. Not very hard for you. Right. I see some of you pass up the homework. You are not really sure about this. Okay. But never mind, we draw it. Right. W. Right. And then this one is T1. This one also T1. The direction, put it in. The direction. And then make sure it go in one round. Right? It can go in one round. 2, 2, 2. Go back. The other answer will be this way. T1, T2. Right? T1 and not T1, T2, but T1 and then W. This way. Right. So both are okay. No worry. Both are okay. Now, angle. So we know that the T1 to the horizontal is 60. Okay. T1 to the horizontal. I draw one horizontal. Right. This is T1. This is horizontal is 60. This one is T1. This one is horizontal 60. So Z, 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 here it is 60. 60, 60, 120. Okay. So I know this one is 120. That's all. Now, of course, how much is this? 60 lah. 120. 120 and 30, 30. Right. Because of these two anchor, it is the same, right? 180 minus 60. Minus 120, left 60. 60 divided by 2. Right? That is your these two anchor. Put it in. I drew a little bit. Okay. Now, the other one. This one. 45 degree. Okay. Draw it. How? Okay. Weight first. Going down. Weight. And then 45. And then 45. The anchor no need chun 45. Alright. You just sketch only. Alright. So this one it is downward. T2. Downward weight. No, I don't want to write. This one is T2. This one is T2. This one is weight. T2 and T2. Okay. So make sure it can go in one round. Okay. So you can draw another one. which is, I don't think it is important here. Now 45, right? Here, horizontal to T2 is 45. Okay, horizontal to T2. Horizontal to T2 is 45. Horizontal to T2 is 45. Meaning that here 45 also lah. 45, 45, 45. Right? 45, 45, 90. Right? So this one is 90. Label it in. And then 90, this one, 180 minus 90 left 90. 90 divided 2, 45 each. That's all. That's your answer. All right, 1 mark each only. Right? I hope you can do it. And this is the one that I want to discuss. All right? Essay. I teach you how to answer in essay. Table 7.2 shows a lawn mower. What is lawn mower? Lawn mower is the one that potong rumput, machine rumput, machine rumput, lawn mower, 割草机. Lawn mower PQRS with the different specification you are required to determine the most suitable lawn mower to cut the grass effectively. Alright, so now, based on table 7.2, set the suitable characteristic of the most suitable lawn mower to cut grass effectively. Give the reason. Alright, method to move the lawn mower. Okay, you need to push or pull. This one is pushing. This one is pull. This one is not push. This one is called pull. Right? This one is pull. This one is push. Right? Like what I told you, you mop the floor. You mop the floor, the force that you push have to go downward to compress the ground. If not, you pull it. Yeah. So the grass is not really can be cut. Alright, you have to push. Alright, push. This one is push. This one is supposed to be pull. Right, not push. Right, pull. Right, this one push. So have to be push. The correct method is push. Right, they ask you the method of moving the lawnmower, push toward the ground. Right, why? So the force will be compressed onto the ground. Hey, the cat go into my room. Wait, sorry, Right, the force will compress to the ground. Right, so or more force will compress to the ground, or the Fy will be larger. All right, you can write Fy will be larger. Also can. Second one, size of the cutter blade. Of course, you won't say small, right? So large. Can cut more glass. Right? Can cut more grass in one time. One time you turn, then you can cover more area. Right? The angle between the handle and the horizontal. Okay. Here, the angle is 30. Alright? You compress. First of all, you got this Z, Z, Z. Here is 30, here is 35. Here is 35, here is 35. So, you got the force here that going downward. Touch, or not touching, right? Use sine 35. So, let's say this one don't have any number. I just said 10 Newton. Test 10 sine 35. How much? 10 sine 35. You got 5.7 Newton, right? If you just 20, F 10 sine 20, right? 10 sine 30, 20. You find it, this one 3.4 Newton only. This one lesser. This one lesser force, right? This one is 35. The bigger the angle here, the larger the component of the force going down to the plane, going down to the ground, go to the ground, right? So angle is this larger angle. Why? More force compress onto the ground. Right, larger Fy. Fy will be larger. Okay, same. All right. All right. So we try to look to page 114. Page 114. The diagram 2 shows a box of the mass 20 kg in the inclined plane with the angle of 30. With frictional force between the box and the inclined plane, it is 100 Newton. They gave us, right? What is mean by frictional force? Frictional force is the force against the movement of the object. Force that against. Right? Okay. It stopped you from moving. Calculate the weight. Weight, just weight 20 times 9.81. Times 9.81, 19.43. 19.42. Eh, 196.2. I'm sorry. 196.2. Alright, I'm sorry. Calculate the resultant force parallel to the inclined plane. Right? They want the resultant force parallel to here. Resultant force means this one, I resolute it to here. And then minus here. This is my resolution of force. So, I draw it first. This is the weight. The weight they have drawn it already, but very short. I make it longer. If not, this one hard for me to draw this angle. Right? This is 30. Okay. Now, this one is 196.2. And then you bring to here. Touch or not touch 30? Touch or not touching 30? Touch or not touching? Not touching, right? Not touching, you use sign. Alright? And then minus here. That is your resultant force. Okay. So the resultant force is equals to 196.2 sine 30 minus 100 times sine 30 minus 100. And negative. How can it be possible? Why negative? 196.2 sine 30, correct? Calculate the resultant force parallel to the inclined plane. Yeah, 196.2. So the resultant force is equivalent to 196.2 sine 30 minus 100. See? Negative. Negative 1.9. Negative 1.9. Right? Okay, I try to look at the answer. Oh, 2021, I know liao. 2021, that time, we still use G as 10. This G as 10, right? 200 times 10, it is 20 times 10, 200, right? So this one is 200 sine 30 minus 100. 200, 20, 20, 200 sine 30 minus 100, 0. Okay, this one is 0. Okay, that time we still use gravity as 10 lah. Right, but never mind. We look at the answer, see whether got answer or not. 2021. You don't have, I guess. Wait, Sabah. Sabah, I don't have answer. Wait, Sabah. Kertas 1, kertas 2, don't have answer. Not, Okay, but never mind, you follow this because of we changed to use the gravity 9.81 already after 2021. Based on the answer, what will happen? So the box will stay. The box will stay at rest. It will not move. Alright. If the force here bring to here minus here, it is more than 0. Then it will start to going down. Okay. So if the force go here, here, and here, it is the same. It will not moving or it will move with constant velocity. But this one is less than, so it will not move. I repeat, you see, 196.2 sine theta. 196.2 sine theta is 98. So the force that going down here is 98 Newton. You pull down is 98 Newton. The force that going up is 100. Will you move downward? No. Now, teacher, will it move outward? So this one is frictional force. The frictional force doesn't pull it upward. Okay? Alright? Okay. Now, the next one. 2021 again. Alright? But never mind, we do it. This is your homework, I try to do as much as I can. I do until 8:30. So 8:30 we continue with the elasticity, right? Hooke law. All right. Diagram 11.1, 11.2 shows a Logan sliding down on a slide at the angle of theta 30, theta 45. One is 30, one is 45. Right. The frictional force is acting on the Logan at the both side. It is the same, right? The weight, it is 250. Wx is component of the weight parallel to the side. The resultant force is Fx, which is equivalent to Wx minus Fg. Alright. So what is mean by resultant force? This one I don't want to do already. What is mean by resultant force? Right? We answer many times already. Alright. So resultant force, it is the vector sum. One or two more forces act on a object. Okay, now using the 10.1, 10.2, compare the Fx, Wx, Fx, and the angle, 3 mark. Relate this one, 1 mark. Conclusion relationship between this one, 1 more mark. Okay, now Fx, Wx first. Wx 177, 125, 177 is more than this. All right. Wx in diagram 11.2 greater than 11.1, 1 mark. First mark. Second mark, Fx. Fx Compare. Now, how much is the fx? Fx is W fx. Where is fx? Oh, fx is here. Wait, here. What is fx? Fx is Wx minus Fg. So Fg how much? Fg. Frictional force is the same. Let's say 100. Let's say 100 lah. Both side So Fx is this one minus this one. Right? 177 minus 100. 125 minus 100. So of course you got this one bigger. So this one is bigger minus this one. This one is bigger minus this one. This one minus, after minus you got 77. This one after minus you got 25 only. So the larger the Wx, the larger the Fx. So Fx 11.2, it is larger. Okay. Now, next one, the angle, 45, 30. How to write? The angle in diagram 11.2 greater than 11.1. That's all. No need to change. So hard to change. I don't change. Okay. I mean, I want to pull the angle upward, but why not I pull this whole thing downward? Okay. Alright, so Fx with the angle. The larger the angle, look at this. The larger the angle, this one is the 45 degree. The larger the angle, the larger the Fx. The larger the smaller the angle, the smaller the Fx. Right? You don't believe? We can try to calculate. This one is 45. You bring to here, it is sine 45. This one is 30. Here is 30. You bring the force here, you don't touch 30. You don't touch 30, sine 30. So sine 30 and sine 45. You can see. Sine 30 is, let's say the weight is 100 lah. 100 sine 30, it is lesser. 100 sine 45, it is bigger. Right? You can see the difference. So now relate the Fx. When the theta increase, when the angle theta increase, the Fx increase. Or you can use another one, which is the larger the angle, the larger the Fx. But cannot terbalik. The larger the Fx, the larger the theta. No. Okay? No, please. Alright, lastly, relationship between the acceleration and the theta. The larger the theta, the larger the acceleration. Alright? The larger the angle theta, the larger the acceleration. Right, that's all. Okay, next one. Okay, so we continue. Diagram 11.3 show a stationary block on the smooth inclined plane when a force P is apply horizontal on it. Here. Here. W. W is the weight of the block. R is the reaction from the inclined plane. Sketch and label the triangle of forces. P, W, R represent this situation. So this one 4 mark. Sketch maybe 2 mark. Label the angle. Label the triangle. Right, P, W, R, and then lastly, the angle must be in 4 mark. So they want everything just in. So first of all, you got a weight going down. You got the angle here. You got R here. And then you got the angle alpha. Okay, so put it in everything. W. And then R. Okay. Alright. And then P. P is here. P is here. So this thing, the most important thing is here. This one telling me it is in equilibrium, not moving. Right? Equilibrium. Okay. Now I am going to do equilibrium. Right. So one, weight going down. Okay, weight going down. And then this one is P. This one is P. And then lastly, this is R. That's all. Okay. So I still got another answer. I draw it, but I don't want the label. I just draw a letter. Right. This is W. This is P. P, P, and then this is R. W. This is P. And then this is R. So I draw another one, which is now W, then R first. You draw W first. And then R here. And then lastly P. Alright. Let's say teacher my W here. W going down. W going down. And then your R going this way. And then teacher not Juno. P not Juno. Not June, you adjust a little bit lah. Come on, you're not from 1 from 2 already. Adjust until it is going horizontal. You don't do it this way. Teacher, tidak Juno, tidak boleh oh. Aduh mak. You adjust until it can go horizontal. Right? So this is your P. I said I don't want to label. I still label. This is R. And then this is W. I label both. Either one only, not both. Just one. Draw one only. Okay. And then, do you think this one can get format? I purposely don't want to put in the angle. I see. What is the answer? 2021. SVP got answer. SVP. Jawapan. Question 11. Question 11. Okay. We read this one. Here. Mark 1. 11.2 more than 11.1. Right? So 11.2 more than 11.1. 11.2 more than 11.1, 11.2 more than 11.1. This one increase, Fx increase. This one increase, F increase. The larger the angle, the larger the acceleration. Okay. Now, here. This one atau this one. Okay. See where is the mark? Draw and label correctly for W. Okay. This one 1 mark. Draw and label for the R 1 mark. So I got 2 mark already. Mark correct the direction of W and R. I also got it. Right, W and R. Right, 2 mark. And then kedudukan alpha yang betul. I don't have it. I don't put in the angle. So I got 3 marks here. Right. Sometimes it is 2 marks. Sometimes it's 3 marks. Depend on. This one, it is not compulsory like that one. So it can change. Right, it can change. So I didn't put in. So now, here it is. Hey teacher, I don't know how to see W the alpha, the angle. Never mind. You draw W down. And then this one it is in between the angle. So this is down in between the angle. So this is alpha. So obvious, right? Here. You see? The shape is the same. Teacher, this one don't have. Okay, this is W. Now this one is alpha. Teacher don't have. Alright. So isn't it W here? And here alpha. This one is alpha. This one is alpha. Da. That's all. Or Z Z Z here alpha lah. Mathematic lah this one. This is the alpha. This is the alpha. Okay. Okay. Now come to the essay question. I really want you to try this question. Although some of them you maybe you are not sure because of this one. None of you pass it up to me. You pass up my homework, but you didn't pass up this one. This one it is important. I want you to try to do it right now and pass it up to me right now. Okay. Diagram 11.4 shows a larger number of the vehicle using the bridge during the peak hour. Using appropriate physics concepts such as modification on the bridge structure so that it can be safer based on the characteristic of the cable, tower, and pillar. Right? Where is the cable? Where is the tower? Where is the pillar? You try to have a look. Right? Characteristics of cable, tower, and pillar. Do it right now. I give you 10 to 15 minutes. 10 to 15 minutes. So you try to do it. I'll be right back. Right? At 30 we discuss. You rest for a little while. You do. All right. Do it right now. Have you done it? 7 minutes. This is the first time I teach you how to answer essay question. Okay. I think I should do it. Characteristic, reason. So this kind of question you answer in table form. Okay. I want you to answer in table form. Try to learn how to answer in table form. Characteristic, reason. So the characteristic got two way to answer. Some of your teacher will give another way, right? Which is some of your teacher will teach you in this way, but both are okay. I like to do in this way. I see how I do. So first one is aspect, and then characteristic. Reason. Okay, like for example, cable, characteristic of the cable. Right, you write the aspect first. What kind of aspect do you have? Like for example, height of the cable, size of the cable, diameter of the cable. Right. So let's say height of the cable. No, height pula. Height cable, diameter of the cable. Size of the cable, diameter of the cable, diameter of the cable. So you said here large, and then why you explain. Do you get what I mean? Right. For example, tower. All right, the tower have to be high or low. The anchor have to be big or small. So you write here, and then here you just simply write the characteristic, and then reason. right? But if I personally like to write in this way, characteristic and reason only, all right? Of course, when you do, you put it into the table lah, right? You draw your own table. Okay, so see how I do it. The characteristic of the cable, all right? So first one is, I think, the thick cable. All right, the cable have to be thick, or diameter of the cable must be big. Why? All right, withstand high tension. All right, so it is not going to break easily, or you can say not break easily. All right, thick cable. And then characteristics mean you have to put more on the cable, more on tower, more than one. If not, your mark is not enough here. Right? Thick cable, strong cable, right? Strong cable, not break easily. Withstand more force, right? Withstand high tension, not break easily. Now, try to use the word of strong, not hard. Don't use the word of hard. Use the word of strong. Why? Because of strong not necessary to be hard. Hard not necessary to be strong. Alright? Hard can be strong, but not necessary. Okay? What does that mean? I give you an example. For example, glass. Glass, it is hard or not? Yes, hard. Strong or not? Not strong. Alright? It can break easily. It is hard, yeah. Okay. Cable. Any other more? Cable? Don't have, Tower. Tower. Larger diameter. Tower with larger diameter. Right? Not tall. Larger my diameter, huh? So, tower. Tower larger diameter. Stronger, right? Not fall easily. Not topple easily. I'm thinking I'll use which word, right? Stronger. Okay. Tower. Tower. High. Higher. Tower. If the tower is higher, so the angle will be small. Right? Smaller angle. Smaller angle, higher tower. Right? Smaller angle. So more force. Compressing downward. 1, 2, 3, 4. All right. Pillar. The pillar. Strong pillar. Why strong pillar? A strong pillar. Withstand more force. Pressure or force lah, also can. Both are okay. So more 1, 2, 3, 4, 5. Right? So if can, you write more. But never mind. We try to have a look into the answer. See what the answer given. Now, strong cable or steel cable, right? Up to you. Right? Not rust easily, not easily break, withstand more force. All are okay. Right? Pillar, concrete pillar, strong pillar, okay. Right? Not break easily. Steel cable, steel cable, right? Same lah. Okay. Alright, they use this, Okay. Next one. Many number of cable. Yeah, why I didn't write it? Right, withstand more force. Right. Many number of cable. Right. More number of cable. Right. More number of cable. Right. Withstand more force. More number of cable. Right. More number of cable. High tension of the cable. Right. Big force. High tension. Withstand more force. Okay. Bigger force. Bigger force. Not break easily. Right. Higher height of the pillar is high. Avoid water spill on the bridge. This one. They want avoid the water spill the bridge. Okay. The height of the pillar is high. Okay. Now, the diameter of the pillar is big. Right. Increase the stability. Yeah, I didn't write this. Diameter big. Diameter. I didn't write about the diameter. Right. Because here got thick cable already. So, you can write diameter. Right. I didn't write. More number of pillar. You can put. No lah. I better write. Diameter of the pillar larger. Larger diameter. Why? Increase the stability. More stable. Lastly, more number of pillar. More support force. Right? Support more force. Support more weight. Okay. Now, when they mark, they are going to consider, right? You see, 1 plus 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So they got 16 mark for you, right? You got 16 mark for you, maximum only 10. Meaning that if you write more, they will not mark you wrong, right? They will give you correct. Right, you write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, cikgu, 10, right? But if you correct, they will give you full mark. Right? If you wrong, like for example, you write one wrong, then they will not give you the mark. They will not minus your mark. Right? Okay. I hope you're okay here. So, you see my homework really a lot. I told you. Right, so I am not going to do this. I don't do this. We do some enough. Others, you pass up, then I will mark for you. If you don't pass up, then I don't mark for you. Right, make sure you pass up so that I can mark for you. Right. So we are going to move to the last part. Elasticity 1.4. Elasticity. First of all, what is elasticity? So this one you have to memorize. Right. Frequently come up when they ask elasticity. Ability of the object to return back to the original shape and size when the force applied on it are removed. So when you pull something and then you let go, then it can return back. That one is called elastic. The guy that study about this one, it is called Hooke's law. Right? Hooke's law said that extension of the spring is directly proportional to the force applied on the spring, provided the elastic limit of the spring is not exceeded. Okay. So this one you need to memorize. Where F is equal to Kx. F is force applied. K is spring constant. So this spring constant, normally you use Newton per meter, but can be Newton per cm. Depend on the situation. I'll tell you what situation need to use which one better. Okay. Now, lastly, X is the extension of the string. You can use meter or cm, up to you. Alright? Not up to you, up to the question. Okay. First one. Now, the graph that you plot here, F against the X. So you plot it in the experiment, you plot, alright, your result you plot. So you're gonna get a straight line, directly proportional. Directly proportional. But in the experiment, normally we are going to do it this way. X and then F. Alright. So this one is F against X. Why? Because of Hooke's law said that force is directly proportional to the X. Force is directly proportional to X. If you write this one is X is directly proportional to force. Right? Actually, both are okay. But why Hooke used this? Because of they want to calculate the area under the graph. Right? Area under the graph and the gradient. Right? So now, first of all, gradient. What is gradient? Gradient is it is spring constant. Spring constant, right? Why? Because of you are looking for this one divided by this one, right? Right. So F is equal to Kx. K is your spring constant, F divided by X is your K, right? F divided by X, right? F divided by X is your gradient of the graph, spring constant. And then area under the graph is half area. Triangle, right? It is half times F times X. Half times F times X, right? The area under the graph is energy stored. Energy is half times F times X. What is F? F is equal to Kx. This one is Hooke's law. F is Kx. This one X I rewrite. So Kx squared. That's why you get this formula. We call it as elastic potential energy. Elastic potential energy. So you do this experiment and then you plot it, you're gonna get this. Alright. So now this is the example that I gave it to you. So for example, student carry out an experiment to investigate the relationship between extension of the spring X and the weight of the lot W. The apparatus is set up in diagram 1.1. Okay, before you hang, all right. So this one it shows you the 10 cm. After you hang something, you hang 10 Newton, it becomes 12. 12.1234, 12.4 cm. Alright, this one is 10.0. Remember, the ruler you use 1 decimal. Right, ruler you use 1 decimal. Okay. And then you hang this one, you check how much. You hang 30, you check how much. You hang 40, you check how much. You hang 50, you check how much. So now, what is the manipulated variable? What is the responding variable? Okay, so you look at the graph. They ask you to plot X against W. So X is your responding, W is your manipulated. But teacher, what is X? You read the question again. What are they saying? They said, oh, X is extension of the spring, responding. Responding, extension of the spring. What is the manipulated? Weight. Okay, I recheck. I check one more time. See whether correct or not. So they said weight of the lot, comma W. So I copy exactly weight of the lot. I don't want to use my own word to use it. Alright, weight of the lot. Okay, so after you do it already, L naught it is 10.0 cm. And then you do, you will get the graph. Alright. So here I am not going to spend time on it. Okay, you will get this. You will get this. And then you will get this. This is F. Hey, sorry. This one is X. Extension of the string. This is W. Okay. You plot the graph, how you get it. This one I don't plot. Right. When you are free, you go and plot it. Because of this one, it will use up a lot of time. So I don't want to do. Now, calculate the gradient. So I don't plot. I don't have it. Yeah, I should do or not. If I do it, definitely cannot finish this one in 1 hour. I mean, never mind lah. I do lah. Alright, I do it. I'll do it. Okay. Tabulate your data. Okay, tabulate data, huh? Okay. I'm thinking of how to cannot do lah. Okay. So okay, table. This one cannot put in table. Can or not? Wait insert table. Wait, I see. Can or not? Edit. Insert image. Insert file. Insert document. Cannot. Oh. Okay, never mind. W stroke. First one is W. Newton. Okay. So first one is 10 Newton, 20, 30, 40, 50. Okay. Second one is length. Length it is. And then length and then X. So what is L? L is the one that you read. Right? L here. L here. L here. Right? L here. Right? So the first one L naught is 10.0. And then 12.4. 14.8. If I read wrong, do let me know. 17.2. 19.6. 22.0. Okay. Now put in the L. L stroke in cm. L stroke in cm. I forgot the number. L 12.4. 14.8. I remember too. 12.4, 14.8. 12.4, 14.8. 17.2, 19.6. 17.2, 19.6, 22.0. Okay. And then X. X is, okay, teacher, I don't know what is X. Never mind. They will tell you. Read the question. The question will give you, what is X? They will give you. Here. X is L minus L naught. L minus L naught. L naught is 10, right? Okay. So X is L 12.4 minus L naught is 10, 2.4. Okay. Must be consistent 1 decimal. All consistent 1 decimal. Cannot salah decimal, one decimal. Okay, so after that you plot the graph. After that you plot the graph. I put it to here first. They want X against W. So X is here. This is our X. This is our X. This is our W. This is our W. 10, 20, 30, 40, 50. Okay, and then the X here, it is the biggest one is 12, right? So 1, 2, 3, 4, 5, 6, 7, 8, enough, 9, 10, 11, 12 until here. So I am going to put until here. Okay, 1. Okay, make sure your y-axis and put it in, right? So what is y-axis? Y-axis, it is X. You need put it in cm. What is this? This is W in Newton. Okay, so I'm going to plot it from now. Okay, so 2.4, right? 1, 2, 2.4. 2.4, it is somewhere here. When 10, 2.4, 2.4. 2.4, 4.8, it is around here. 7.2. 30, 7.2. 7.2. And then 9.6. 9.6. 12.0. Okay, and then you're gonna find the best fit. Right, I make this one smaller so that I can find the best fit. Okay. Must go through 0. Very nice graph, right? Very nice graph. It hit all the point. Most of the time it cannot hit all lah. Right, most of the time. So you try your best to get the best answer. Right, best fit. If you are not sure, you go to my channel to find the Form 4 chapter 1. I do teach you how to find the best fit. If you're not sure, you can PM me lah, also lah. Right. Now, first of all, calculate the gradient of the graph, right? To determine the K. Okay, gradient of the graph. So how to find the gradient? Gradient, first of all, you need to draw a triangle. Right. I make it smaller. Draw a triangle. So draw a triangle. Don't use this point. Use this one. Use this one. Right. So it is about very small. I make it bigger so that I can see. Wait. Okay. Use this point. 11.9. 11.9. 11.9 minus 0. Okay. Gradient. (11.9) minus 0 over 50 minus 0. What is the unit here? It is cm. What is the unit here? It is Newton. So your unit can be cm per Newton. 11.9 divided by 50. You get 0.24238 Newton per cm per Newton. I'm sorry. Right? Based on the graph, set the relationship between x and w directly proportional. X is directly proportional to w. Okay. If a spring is added parallel to the 1.3, what happened to the extension of the string? This one I haven't teach you yet, so it will be decreased. The extension will be reduced. Okay. Next one. Okay, so this is how you plot the graph. But one of the thing is, now the gradient here cannot do anything. This one, it is the gradient is cm per Newton. It is not equivalent to k. F is equals to kx. F is kx, k is equals to f divided by x. So this is your spring constant. But this one is not your spring constant. In case they ask you to find the spring constant, so you have to 1 over 0.238 to get the spring constant. The gradient of the graph for x against w, it is not spring constant. You need to know this. It is not spring constant. Okay? Alright. So, okay. Now, we go into detail. Factor that affect the stiffness of the spring. So, what is stiffness of the spring? Is how hard is the spring? Stiff or not? Hard or not? Right? So, if the stiffness it is high, mean it is stiff. Very hard to bend. Right? Very hard to compress. Alright? So, now that is few factor. Length of the spring. The longer the spring, the less stiff it is. The shorter the spring, the more stiff it is. Stiff means the K high. Spring constant is stiffness. Okay? The longer the spring, the less stiff the spring. I write it for you already. You don't need to do anything. Just listen. Diameter. Now, the diameter, you have to be very, very careful. Diameter of the string. This is called diameter of the string. More stiff. The diameter, when it is big, it is less stiff. So the larger the diameter, the less stiff the string. But when they said diameter of the wire, you have to be careful. Diameter of the wire mean this one, diameter of the wire. The wire they are using to make the coil. This wire is thick or big diameter. Diameter of the wire. This one is diameter of the coil. Diameter of the spring. Diameter of the string. This one, diameter of the string. Right? It is not diameter of the wire. Diameter of wire, it is under the thickness of the string. So this one you can say the diameter of the wire also can. So you see this one diameter, the diameter of the string are the same. This one is thin, this one also thin. But this one, the wire is this thin. This one wire it is thick. Mean diameter of the wire it is thick. Right? So more stiff, less stiff. The thicker the spring, the more uh the more stiffer the spring. Lastly, the material. For example, steel, it is more stiff compared to iron. Okay, if you plot the graph, right, this one against here. So for example, this one, I talk about this one, length of the string. So I got 2. This one is F. This one is X. So this wire, it is gradient, it is high gradient. High gradient mean it is stiffer, right? This one is stiff, right? Shorter wire, right? Longer wire. And then the diameter, so this one is less stiff, this one is more stiff, right? Smaller coil, smaller diameter of the coil lah, right? So if I write diameter only, then smaller diameter. I takut you said smaller diameter of this one, so I said smaller coil, right? Larger coil. So the thickness of the wire, right? So this one, it is thick. This one, it is thin. And so on. Okay. Now, arrangement of the spring in series, it is in this way, right? One, and then you hang one more under here, it is arrangement of the string. If 2, we call it as parallel. If series, the extension, it will extend more. This one will extend more. Right? This one extend less. Okay. Now, it is a time for me to teach you how to calculate. And then normally, this one come out in objective. If you can do it without calculating, then very good. Alright. So, now, I don't want to see this one. Alright. I want to see this one. See whether you can do it common sense or not. You hang 1 Newton from 10 become 12. You hang one more, alright, 2 Newton. 1 Newton become 2 Newton right now. 1 Newton extend 2. 2 Newton, so extend 4 lah. Right, 14. You hang 3 Newton. 3 Newton extend 6. But this one is extend 5 only, from 10 to 5. So this one is not yet 3 Newton, 2.5 Newton. Very fast. You don't need to do calculation. But anyhow, calculation is in this way. So I show you the calculation. We do the simple one first. Number 1. The calculation, we use Hooke's law. F is equal to Kx. F is the force that you put in, right? 1 Newton. It's equal to K. K, I don't know. Extension of the spring, it is from 10 to 12, right? So it is 12 minus 10, right? So this is the extension. So K gonna be, right, 1 divided by 2. 1 divided by 2 is 0.5. 0.5, what is the unit, right? This one is Newton. This one is cm. So Newton per cm. You ask me, Cikgu, do I need to change it to Newton per meter? No need. When do we need? Later. Right? This is not the thing that I want. So what does that mean? Okay, look at this unit. Every 0.5 Newton per cm, you will go for 1 cm extension. So I double up. 1 Newton, it will extend 2 cm. 1.5 Newton, it will extend 3 cm. Another word. 2 Newton, it will extend 4 cm. 2.5 Newton, it will extend 5 cm. So here to here extend 5 cm, it is 2.5 Newton. 2 Newton, it will extend 4 cm, 10 plus 4, right, 14. That's how you get it. Okay. Now, not yet finished. So, again, F is equal to Kx. Now, continue F is Kx. So, now, the F right now, it is 2 Newton. K, we know it as 0.5. Extend how much? I don't know. Right? So, X is 2 divided by 0.5. It is 4. 2 divided by 0.5. So, it extend 4. Extend 4. So, how much is Y? Y is equal to original length is 10 plus 4. So, answer is 14 cm. Answer is 14 cm. I'll repeat one more time. First one, you go to find the K first. Right? K is the spring constant. You go find the K already, then you substitute it in. Number 2. F is equal to Kx. Right? F now, you don't know, right? You don't know, it is W. K is 0.5. Extend how much? From 10 to 15. Right? 10 to 15. It is 5, right? 0.5 times 5. Right? 0.5 times 5. 0.5 times 5. You get 2.5. That's all. Okay? This one's simple one first. We do the simple one first. Alright. So, now this one slightly harder. Right? So, how to do this kind of question? Now, you got the length. Now, you see, I don't want to do first. I just want to show you. Right? You hang 2.5 Newton. 2.5 Newton. Then tambah 2 cm. Not tambah 2. I don't know how many. Right? Tambah how many. Right? You hang 2.5 more. Tambah 2 cm. Two 2.5 become 5. You add in 2.5 Newton in. So it add in 2 more cm. So this 5. This 2.5. So now you remove the 2.5. So it's supposed to go down 2 cm. 12 go down 2 cm. 10 lah. You see? Common sense, you can get it very easily. But anyhow, this one, how to do this kind of question? F is equal to Kx. So we just use one formula. F is Kx. F 2.5. K don't know. Extension of the string. So original is L0. Finally is 12. So 12 minus L0. Okay. So got two unknown. One is K, one is L. Cannot do. So I want to do the second equation here. Second equation, F is Kx. F 5. K same. Because they are having the same string. So the K it is the same. Unless you change the spring. Unless you add in another spring. Parallel or series, the spring constant will be different. If you are using the same spring, the spring constant will be the same. The spring constant will be remain the same. F is Kx. F Kx. X is 14 minus L0. Okay, got two unknown, so I divide them. Okay, 1 over 2. So, ni 1. 1. Sorry, what am I doing? So 1 divided by 2. So 1 divided by 2 is, what do you have is 2.5 divided by 5 is equivalent to 1. So K, I still put it in 12 minus L naught. I copy this one. This one is 14 minus L naught. So I can eliminate, I can cancel the K. So this one cross multiply, this one time up, this one time up. Okay. So what do I have? 2.5 times 14. I'll get 35. 2.5 times L naught minus 2.5 L naught. 5 times 12, 60. 5 times L naught, 5 L naught. Okay, L naught and L naught we move together, right? So this one negative, I want this one, right? 5 times L naught, 5 L naught lah. So I move this one to here. 5 L naught become this one already minus 2.5 L naught. I repeat, I time it up already. So this one I move to here, become positive. Right, this one remain to here, minus. Right, this one is 60. And then 35 move to here, become minus. 60 minus 30. 60 minus 35, I'm sorry. So this one left, 2.5 L naught. 5 minus 2.5 left, 2.5. Right, 60 minus 60 minus 35. Why 35? Okay, 60 minus 35 left 25. So 25 divided by 5. So 25 divided by 5 it is 25 divided by 5 is 2.5 is you got 10. Right? So L naught it is 10. That's all. It looks like complicated, right? I repeat one more time. F is equal to K X. Extend how many? 12 minus L naught. Right? And then first equation, because got two unknown. Right? Second, F is equal to KX. X is 14 minus L naught. Okay? So you solve them. You get the answer. Second one, find the spring constant. Right? Spring constant. So now substitute this one into 1. Okay? 2.5 is equals to K 12 minus L naught. L naught is 10. Okay. So this one divide 2.5 divided by 2. 2.5 divided by 2. You get 1.25. K is equal to 1.25. This one is Newton. This one is cm. So your unit is Newton per cm. Newton per cm. Okay. All right. Okay. What if the thing give in this way? Okay, we try to have a look at. Now, find the spring constant K, right? Number 1. Right, example number 33. F is equal to Kx. F is 0.5 Newton. Kx, K I don't know. X, extension, extend. Now, don't tell me, teacher, this is 10 minus 12, right? 10 minus 12. Just now it is 12 minus 10. This is 10 minus 12. This is negative 2. No. Extension, we don't take negative number. We always take big minus small. Right? We always take big minus small. Right? Remember, only take positive number. Right? 12 minus 10. You ask me, Cikgu, just now it's final minus initial. Just now it is final minus initial. This one is final minus initial. Final minus initial. This one is final lah. Final minus initial. No. We take big minus small. That's all. Okay. 0.5 is Kx. So K gonna be 0.5 divided by 0.5 divided by 2. So you get 0.25. Unit is Newton per cm. Newton per cm. Number 1. Okay, number 2. They want to find this one, right? So what is P? How much is P? Right? Okay, F is Kx. F is 1.5. K I don't know. K I know. 0.25. Extend how many? I don't know. Alright, I want to calculate. So now 1.5 divided by 0.25. 1.5 divided by answer just now is 6. Now you need to know originally it is 12. 12. And then this extension this extension means it compressed 6 cm. 12 minus 6. So P gonna be 12 minus 6 cm. So it is equals to 6 cm. If you don't show, teacher, I do until here. P is equal to 6. Alright, X is 6. Yeah, same. This one is your compressed down 6 cm. Original is 12 minus 6. So you have to show this one again. Even the answer is the same lah. Alright. Okay. Now. So that's why this one it is more complicated. I need to show you how I do it fast without calculating, right? Without F is Kx to calculate, right? See how I do it. If you can, you follow. If you cannot, then you have to do one by one. Okay, see how I do 1 Newton extend 2. 2 Newton extend 4. This one supported by 2. So 4 divided by 2. So this one gonna be original is 10. Here is 10. 10 plus 2. 10 plus 2. Here is 10 plus 4. It is 26. Finish. Okay, so I drew this. 1 Newton plus 2. Right, 10 become 12 plus 2. 2 Newton plus 4. 3 Newton plus 6. This one plus 6 divided by 2. Because supported by 2 spring. This one plus 6 divided by 3. So plus 6 divided by 3, it is plus 2, plus 3, plus 6. Original length is 10, 10, 10, 30. 30, 41. Finish. See, I can do it very fast without using hook law. Right? You don't need to use hook law, also can. If your objective, you can do it this way, then very, very easily. Right? For example, okay. But anyhow, okay. Now, you see, I can use within less than 1 minute to do the two questions very fast. But anyhow, when we use hook law, okay, so we need to F is equal to Kx. So here, F, you find F is equal to 1 Newton, K I don't know, X is 2 cm, extend 2 cm. So your K gonna be 1 divided by 2 is 0.5 Newton per cm. Okay, I found the K already. I found the K already. Now F is Kx. F is Kx. Now here, we do this one first. This one, F 2 Newton. K is 0.5. X I don't know. So 2 divided by 0.5. 2 divided by 0.5. It is 4. My X is 4 cm. It will extend 4 cm for this one. When it is supported by 2, so it is harder. The spring constant will be higher. Here, my notes got. Where? Yeah, too high. The spring constant will be higher. So this one, the spring constant will be higher. The extension will be lesser. The spring constant will be higher. So this one I will set extend lesser, spring constant higher. Alright. So this one normally I am not going to use spring constant what. Alright. Very hard for you to do. But never mind, I'll show you how to do it later. See. Okay. F is Kx. Alright. So now this one, the spring, it is more. 2 spring parallel. So F is Kx. Now F is still 2 Newton. 2 Newton. Now because of 2 spring, the K become higher. So it's 2 times K. 2 times 0.5. Now extension I don't know. 2 divided 0.5. Right? 2 divided 2, it is 1 divided 0.5, it is 2. Right? So you got 2, X is 2. X is equal to 2. Okay? So, meaning that here extend 2, here extend 4. So, total length P is 10 plus 2 plus 10 plus 4. So altogether is 26. Okay, I repeat one more time. Maybe some of you still blur. Cikgu apa lu cakap? Okay, here. See ya. So I find the K first, spring constant for one spring. So one spring, right? Only for one spring, 0.5. Okay, now I calculate if I hang 2 Newton, what happened? So it said that it will plus 4. I calculate already. Now 2 spring in parallel. So here I make a short notes for you. 2 spring parallel. Two spring arranged in parallel. But I write 2 spring parallel easy lah. Don't want to make it hard. Right? So times 2. 3 spring times 3. 4 spring I times 4. The K is 0.5. Right? 2 times 0.5 because of 2 spring arranged in parallel. Alright, so I calculate the x extend 2, meaning that here extend 2, here extend 4. Originally, it is 10. Cikgu, this one 10, this one also 10. Oh. 10 is still 10 because of they are parallel. Not 10, 10, 20. No. Okay? So, original 10, you extend 2. Original 10, you extend 4. 10 plus 2 plus 10 plus 4. 10 plus 2 plus 10 plus 4. Okay, 26. What about we try to do it this way? So f is kx, we got it already. Now we are going to do this one. Yeah. F is kx. F is kx. This one is one spring only, 3 Newton. Right? K is 0.5. Extend, I don't know. Right? So x gonna be 3 divided by 0.5. So 3 divided by 0.5, it is 6. It is 6. Right? So this one extends 6. If you takut, you forget, you plus 6 here next time. Okay. Now I want to calculate this. F, 3 Newton, right? You hang 3 Newton. For example, this one, this lot, you put it to here. Easier for you to see. Because of 2 spring. 2 spring, 3 Newton, 2 spring, 2 times the K. 2 times 0.5. And then times X. 2 times 0.5 is 1. 3 divided by 1 is 3. So I made a short note for you here. This one. 2 spring parallel. Right? So you know here already. So this one extend 3. You hang 2 together, 2 spring together, you extend 3 cm. Now you calculate this one. How much? 3 spring together, 3 spring parallel. F is kx. F 3 Newton. Right, now 3 spring together. 3 times 0.5. Your spring constant is 0.5 times x. 3 divided by 3 is 1. 1 divided by 0.5, x is 2. Okay, so why this one times 3? 3 times 0.5 because of 3 springs together. Three string parallel. So now total extension will be total length. You check the question. What do they ask you? Total extension is 6 plus 3 plus 2. But total length of Q. Total length of Q is original 10 plus here extend 6, extend 3, extend 2, extend 2 lastly. Right? 10 plus 6 plus 10 plus 3 plus 10 plus 2. Right? So it is going to be 41 cm. Total length of Q is this much. Okay. Are you okay with this? Still got one more, but this one I don't want to teach you first. I don't want. Now, I want to talk about one of the students asked me this question. Where? I go and find last week. Last week I tell you, maybe you don't understand. You see? I try to okay. I try to re-explain what do you have here. If I remember, then I do lah. If I don't remember what to do, 50%. Okay. Now, original length it is 5 cm. Extend 2 cm. They said lah. Total extension how much? Total length how much? You hang 100 Newton, right? So I don't know what is this, right? like hang, total is like x is 2 cm, mean you hang 100 Newton, you extend 2. Okay. Now I do it. This one plus 2. You see. This one plus 2. Eh? Why like that? Oh. This one plus 2. Yeah. No. Wait. Still big. I want to make it smaller. Okay, like that. Okay, enough. Here plus 2. Here plus 2. Here plus 2. But now you divide. Because it is shorter. 2 string harder to pull. So plus 1 only. Plus 2. This one plus 2. But divided by 3. Finish. Finish. So total length is length total extension first, the question. Total extension is total extension. Total extension is 2 over 3 plus 2 plus 1 plus 2 plus 2. Finish. Finish. Okay. Now, if total length is, this one is original, it is 5. 5 plus 2 over 3 plus 5 plus 2 plus 5 plus 1 plus 5 plus 2 here plus 5 plus 2 here plus 5 plus 2. That's your answer. Do you get what I mean? Now, I hope you can understand. But now, teachers, how about in series? Okay. Now I want to talk about series, but I don't want you to use it. Teacher, you not giving series. Yeah, I didn't give any example about the series. So now I give one example on series one. Okay. Now, if original length, okay, I make it this way. You don't need to copy. Just listen. Just listen. Okay. Original length is 10. You hang 100 Newton. 1 Newton lah. 1 Newton. It become 12. 1 Newton extend 2 cm. Alright. So if you do it this way, so 2 spring together. Right? 2 spring. So what is your extension? If you hang 3 Newton. Now you see how I do? I do the purple one for you and the one that without the purple step one. Okay. You see 1 Newton extend 2. 3 Newton extend 6. Finish. 12. 10 plus 6, 10 plus 6. Total extension is 10 plus 6 plus 10 plus 6. But if I want to do F is equal to Kx, F is equal to Kx. Now, you have to do one by one. If you do two together, I takut you salah. Okay, I'll do it for you. F, 1. K, I don't know. X is extend 2. So K is 1 divided by 2 is 0.5 Newton per cm. Now I apply into here. F is equal to Kx. Teacher, this one series. Series, this one is 3. Series, cikgu, you said parallel times 2, right? Series divided by 2 though. Okay, 0.5 divided by 2. Yes, correct. X. Right? So, X is 3 divided by 0.5. I said 0 divided by 2. Divided by 2. What divide by 0.2? Divide by 2. Okay. So, 0.5 is your K and then you divide by 2. Why divide by 2? It is series. Okay. So, 3 times 2. 6 divided by 0.5. So, extend 12. Yes, extend 12. X is extend 12. So, total extension is 12. Then, What is the total length? When you calculate total length, original is 10 and 10. Teacher, 12 is for 1 or for 2? You don't know. You tidak pandai. Don't know. Or some of you teacher 12 extend 12 original is 10. Extend 12. Salah lah. It is 10 plus 10 plus 12. It is 20 plus 12. Easy for you to get wrong. So don't do it this way. Don't do it this way. When series, cikgu, don't do it this way. Do it what way? Okay, now I do it. F is equal to kx. K is 0.5 for one string. So this one 3 I hang to here. 3 Newton. K is 0.5. Extend how much? I don't know. Okay, divide. 3 divided 0.5, 6 cm. You hang 3 here. F is kx again. 3 is equal to kx. X is still 6 cm. So here plus 6, here plus 6. So total length is 10 plus 6 plus 10 plus 6. Will you get wrong? You won't get wrong. So only series you time 2. Parallel, you do it separately one by one. You get what I mean? You don't mix them together and then divide by 2. You make yourself hard. No. Alright. Like this, if you want to calculate, okay. Wait, you see, now if this one complicated time 2 divide by 2, this one, you campo, you surely forget one. This one extend how much? No. So you just do one by one, right? This one times 3, like k times 3. This one k times 2. This one you do one only. 100 Newton you hang to here. This one 100 Newton you hang to here. 100 Newton you hang to here. Finish. You no need to divide by 2 times 2. No need. Get it? This is how we do it. Okay, still got one more, which is spring constant and elastic potential energy, and some more exercises. All right, so the exercises homework how you, I tell you really a lot. What to do? I give you lah. You can do, you do lah. I don't want to force you. But the energy store in the spring I haven't teach yet. Don't want to give you an homework lah. If you want to do, you can try to do on your own. The rest from 143 until 260 pages. My homework a lot lah. Alright. So I'm gonna stop here. So next week, remember, if you haven't paid the tuition fee, you need to pay before 7 because of start from February. It is no more free, right? So the fees are already put into the group, so you check it. If you haven't pay, I will remind you one more time lah later. You haven't pay, you pay for it. If you don't know the account number, you ask me again. If you got friend want to join, you ask them. You want to join, you join Mr. Lee one. This Lee one best one. Okay. Alright, I'm gonna stop here. I'll see you next week. Bye bye.